Hello students, today we are going to discuss electrostatics charge distribution concept. This is a very small concept, required basic concept. Using this we have a lot of problems can be solved in the coming topics. So what is charge distribution? Already in the previous classes we discussed about whenever you taken any body, the charges will be distributed on the charged body. So that charges, whatever it is distributed on the charger body, that will be accumulated on the charger body on the surface of the charger body. This is the thing we discussed in the previous. Whenever you taken any charger body, the charges will be accumulated on the surface of the charger body as you're looking like this. Right now, these charges will be occupied according to the type of shape of the body. If the particles are distributed along the length, the charges will be distributed only along the length. If the body having area, more surface area, the charges will be distributed on the area. And if the body having volume, the charges will be distributed on the volume, because there is atom, there is a charge. So here the charge distribution basing on the atom distribution. So atoms can be distributed linearly, one, and aerially and volume wise. So here, if you want to understand this one, you consider one of the thin wire of negligible area of cross section. If you given a charges to this one, the charges will be accumulated on this one as you're looking like this. In this case, the charges which are distributed on this one we are calling as linear charge distribution, one dimension. That is nothing but linear. That means along the length, if the charges are distributed, that is called linear charge distribution. Now, if you taken the second one is one of the square plate, like this is a square plate, like if you taken. Now, if the square plate is taken, if you have charged this body, then what happens? The charges will be accumulated over the surface of the body, that is, which contains the surface area. It may not contain surface area, but across the area, the charges will be distributed. That is nothing but called as aerial charge distribution. And third one, some bodies may have volume. Example, if you take a sphere, solid sphere, if you taken, in the case of solid sphere, the atom will be throughout the body, the atoms will be there, so the charges will be accumulated across the total volume of the body. This type of distribution is called as volume distribution. In the case of halosphere, if we take in halosphere, halo means there is no atoms present at the center, only outer boundaries only we are having the particles, that atoms. That's why charges will be accumulate only on the surface. It is similar like football. So whenever you charge that to football type bodies, in this case the charges will be accumulate on the surface of the body. So according to the way, sometimes the charges will be distributed linearly, sometimes the charges will be distributed aerially, sometimes the charges will be distributed volume wise. So now we are going to discuss in this what is linear charge density distribution, what is aerial charge distribution, what is volume charge distribution, and formula based will derive. After that we will go for problems on this. Now first one, linear charge distribution. Linear charge distribution we are indicating with the letter lambda, where the particles are distributed only along the length. There is no area, there is no volume contained by that body. That means we are compared to length, the area and volumes are negligible in that case. Example, you take a wire, already we discussed, we take a wire. This wire contains the length is L. Now what we are doing is we are giving the charges to this. The charges which are given to this one is accumulated on this surface of this wire. The particles which are on the wire are maybe infinite, maybe finite. According to the condition of the finite infinite, we can able to understand. So if one charge is, if you say small q, the total charge of the wire which is accumulated is capital Q. So total length of the wire is L, and here the charges are distributed according to linear charge distribution called as lambda. What is lambda? We can define the lambda can be defined as it is the charge accumulated per unit length, is called as linear charge distribution. How many charges are accumulated per unit length? This is the total length if you taken, this is the charge if you taken. How much charge is present per unit length compared to total charge? That charge per unit length is called as linear charge distribution. From this you can able to calculate the total charge of the body, that is Q is equal to linear charge density into length of that. Using this one we can able to calculate this. So here what is the lambda units? The lambda units is equal to charge we are measuring in terms of coulombs by length is meter. Simply we can write as coulomb meter minus 1, because this is important in the case of competitive examinations or general understanding of concepts of this. Dimension formulas also they can able to ask. The next one is areal charge distribution. The areal charge distribution we are indicating with the letter sigma. So here consider one of the hollow sphere, or otherwise you take a square plate. Both are contains area. The sphere contains the surface area. It is not having volume. Hollow sphere. This is the plate which contains only area. So in this case, whenever you given the charges to this one, the charges will be accumulate on the surface across the area of the body. So this type of distribution of the charges we are calling as areal charge distribution. In the case of square plate also, the charges will be accumulated throughout the area as a areal charge distribution. This areal charge distribution we are indicating with the letter sigma. So A is the area or S is the surface area if we taken. In this case, I can write sigma is equal to nothing but called as areal charge distribution is equal to, okay, the charge accumulated, the total charge of the body if we say as Q in the both the cases, the charge accumulated per unit area is called as areal charge distribution. Also we can write in terms of, in the case of hollow sphere, surface area, because sometimes the body may not have area, it may have surface areas. In that case you can use this formula. So according to this one, the sigma units we can write as charge we are measuring in terms of, okay, that is coulombs, and area we are measuring in terms of meter square. So if you write the units of this one, coulomb meter minus 2 is the unit we can write according to the condition of this. So this type of distribution is called as what? That is called as areal charge distribution. So if you want to write the formula for this, okay, particularly for the case of sphere, the sphere having radius r, the sphere having radius r. So in this case I can write the Q by S I can write. In this case that is Q by S is nothing but surface area. So the surface area of this sphere is equal to 4 pi r square is the formula for that you have to know before. So from this, what is the total charge of the body means? In the case of sphere, how much charge is distributed on the complete hollow sphere when it is charged is equal to Q is equal to, I can write as sigma into 4 pi r square I can write. So using this one concept we can able to get it. The sigma is called as areal charge distribution. This areal charge distribution nothing but, this is nothing but areal charge density we can also call areal charge density. This density is always constant and 4 pi is also constant. If you taken the constant condition, the charge accumulated on the body is directly proportional to square of the radius of the sphere. So this is one of the relation we can get it. That means if we taken the more size radius sphere, the more charges will be accumulated, less charges will be accumulated on that one. This is one of the, which one? Areal charge distribution. The volume charge distribution we are indicating with rho. This is the distribution where the body is having volume. You take a cubes contains volume, you take solid spheres contain volume. So some sphere like a cone, solid cone if you taken, it is having volume. So whenever you taken the certain volume bodies, that means where the particles are distributed along the volume, in that cases if you given the charges to that, what happens, the charges will be accumulated over the complete throughout the volume of the body. That type of distribution of charge is called volume charge distribution. So here I can take the example of one of the solid sphere. Whenever you taken the solid sphere of radius, certain radius r, if you given a charge to this one, the charges will be, we are writing throughout the body here. That means because the atoms are present inside also and on the surface also, that's why we are writing the charge distribution throughout the body. But in the case of, if you see this one here, there is empty. Okay, in the case of aerial distribution, there is empty space. We are not drawn any charges inside that. Here we are draw the charges in complete area. So this is having volume, right? And charges are distributed. The total charge of the body is Q. Now we can write, we can define the rho. Rho is called as what? Volume charge distribution. The volume charge distribution is equal to, this is the charge accumulated per unit volume, is called as volume charge distribution. In the case of this sphere, I can write that volume charge distribution like this. Rho is equal to Q by, what is the volume of the sphere? The sphere contains radius, the sphere having radius. So that the volume of the sphere we can write in terms of radius as 4 by 3 pi r cube. We have to know before. So from this I can write the total charge on the body, okay, which case in the case of volume charge density case, the total charge on this volume of the body is equal to, I can write as rho into 4 by 3 into pi r cube. So this is the total charge on the surface of the body which contains the volume, where the volume distribution of the charge takes place. Where rho is called constant, if we say, in the case of some cases, it may be most of the cases we are taking as constant. In the case of higher advanced level, we have some problems will be there which are variable. Okay, density also is there. Here, constant charge density, that's why it is rho is constant. 4 by 3 also, 4 by 3 pi also constant. So from this I can write the charge distribution in the case of volume charge distribution is directly proportional to cube of the radius. So here the volume charge density unit, what I can write, Q is nothing but, what is the Q? Coulombs. We are measuring volume nothing but meter cube. So I can write coulomb meter minus 3. This is the unit of this one. So these are the points important, and based on this one, we'll go for some example problems now. Now we will have a problem on this based on distribution of charge. You can see the question based on integration method. In the competitive exams, this type of model questions asked in the previous competitive examination. So look at this one. A point charge Q is situated at a distance d, small d, from the one end of the non-conducting rod of length m. So here I taken one of the non-conducting rod of length, how much here? From this, at a distance of small d, we kept a charge Q. That means we taken a charge here, I am taking here, that is capital Q, which is at a distance of d from one end of the non-conducting. That means this is the first end I am saying, this is the second if you say, from this end, this charge is arranged from this. Now, this is the carrying, that means what is it now, the non-conducting rod of length L carrying a charge Q. That means this rod, whatever you take in the length L, it is carrying a small charge Q. Total charge is small. This is the way they given in the question also, so you can see the diagram of that. Now the force experienced by Q charge means this is one of the charged body. So whenever it is charged, what happens? The charges will be accumulate on the body, right? The charges will be accumulate on this body. So this is the way the charges will be accumulate. Now these charges which are accumulated on this one will be, okay, applies the force on this charge because this is also positive charge, positive repulse, there is a force. Now this force of interaction will act between these charges. But here we are not having one charge, and the charges are, we have infinite charges, and these charges also not, okay, at a fixed distance, because if you see this one from the charge capital Q, if you say for example, like we can't take practically, but we can imagine first charge, if you say it is near, second charge here, third charge here. So that means the charge capital Q with a small q, interaction with a small q of the charged body, each charge separate distance are there, separate forces applies. So to calculate the force acting on this capital Q by that charged body, we have to take the, okay, force applied by the each charge onto that capital Q. So it is very difficult because the charged body contains infinite number of charges. So that each charge is calculated, and the addition of all that is very difficult. That's why we are using one of the integration method to solve this one easily. So to solve this one using integration method, so what we are doing is, here I am considering one of the concept called as charge distribution concept. In the case of rod, what way the charges are distributed? In the case of rod, how the charges are distributed? If you see this, the rod contains length L, the charge on that one is small q. So the charges are distributed on that one in terms of linear charge density. Along the length it is distributed, because in the question they did not mention the area, so we should not take any area consideration. So lambda is equal to charge occupied per unit length here. From this I can write what is the charge of that one. The charge on the body is equal to Q is equal to lambda into L. I can write first we got the how much charge on this rod in terms of linear charge density first. Next, this charge whatever it is there, that is applying the force on the capital Q according to electrostatic force of repulsion. So according to electrostatic force between the two charges, what is the formula? F is equal to, so 1 by 4 pi epsilon naught I am taking as K, that is constant throughout the solution, that's why I am writing as K. K into one charge is small q, second charge is capital Q, okay, K into Q cube by distance between them. Distance between them. The distance between them in this case to take we can't take that which charges we are going to take, which charge we are going to take. Now I am writing a just general formula as r squared here, but the q, small q, is distributed different, means starting point one value, ending point another value, because the distance is varying. So for that, to solve this one, what you have to do is first consider a small elementary portion here. Consider a small elementary portion of length. A small portion you take. That portion length I am writing as dx. Small length. That length thickness can be, you can choose it according to your convenience, whatever it is. Okay, dx. Now this dx contains the charge. You take it as dq, a small charge. Total charge of the rod is small q, but the small elementary portion which you taken, that charge on that one is equal to dq. The thickness is dx. Now what distance the dx is present, the position of that chosen is equal to x from the capital Q. Now our understanding of the problem is this elementary portion will repulse the capital Q. Now this elementary portion, how much force it is repulsing with the capital Q, that depends on the position of that elementary portion. I can choose this elementary portion here also. You can say I can choose the elementary portion here also at one position. I can choose the elementary portion at the end also. So as the elementary portion position changes, the force of repulsion also changes. That's why it is called variable concept we are calling. That's why what we are doing is, first I am taken the elementary portion at one of the position, that is called x distance of thickness dx and dq. Now I can keep this elementary portion at first position. If you are keeping here, now what is the distance between capital Q and dx? That is small d. Suppose the same elementary portion, if I chosen at the second position, end of the rod, if you chosen that elementary portion, in this case what happens, the distance between the charge and that elementary portion becomes, from here to here is d, charge to the one of the end of the rod is d, length of the rod is l, total d plus l it becomes. So here you need to understand here, if you chosen the elementary portion at near to the charge end, the distance of that charge will becomes d is equal to x. Sorry, x equal to d. The distance of the elementary portion becomes x equal to d. Suppose the same elementary portion, if you taken at the second position, in this case the x1, x2 position, if you choose the elementary portion, in that case the distance between the charge and the elementary portion becomes d plus l. So here the force between the two charges varies from the position d to d plus l. That is the meaning of this. So here variable force is taking place according to the length changes. So here force is changing with respect to length. That's why this, whatever it is, the force which is changing uniformly and constantly with the same value, because this is one of the uniform charge distribution based we are doing the problem. That's why we are using integration method here. So before going to integration, first we need to calculate whatever the elementary portion I chosen, what is the charge of that one. Already we done. The charge of the body Q is equal to, what is the formula we taken, lambda into length of that. Total charge of the rod is equal to linear charge density into total length of that. Now what is the charge of the elementary portion? The charge of the elementary portion is dq. Dq is equal to, lambda is called as linear charge distribution, that is constant, that is a linear charge density constant, into length. What is the length which is chosen for elementary portion? Blue color one, the shaded one, very small length, that is dx. For complete length, charge is q. For a small elementary portion, dq charge. What is the length of that one? Dx. So charge dq is equal to lambda into dx. Now apply the formula, force between two charges. Here we are calculating the force between the two charges. F is equal to k into, one charge is capital Q. This is single charge. Second one is small q. The small q we are not taken complete body q, we are taking elementary portion. What is the elementary portion charge? That is d. K into capital Q into d by distance. Now what is the distance of that elementary portion? That elementary portion I taken as dx. The distance of that one is I taken as x. So I can write as x square. This is the way you can write the form. Now apply the equation what we derived, that is k into capital Q into, what is dq? Just before we derived, dq is equal to lambda into dx I can write by x square. Now this one we have to integrate. So here I can write as this is dq. Dq means small charge. Small charge means the force is also small force, that is df. So now I can write integral df is equal to, okay, elementary force, elementary charge, elementary force. And integral df is equal to, I can write as, so here before doing integration, constant k is called constant, capital Q is single charge, that is also constant, lambda is called linear charge distribution, that is also constant. All constant I taken out of the integration, and the remaining is I am writing as dx by x square like this. So now this is the main part, you have to solve it. If you solve it, our problem will be solved. In this case, whatever the limits, okay, what are the limits here? The x value starting from where? The x value, that is from d value to, okay, x1 to x2 position, right? x1 to x2, x1 value is equal to d, x2 value is equal to d plus n. Up to this, you have to integrate. So first integral dx by x square. What is the formula for this one? Integral dx by x square is equal to nothing but, we can write this one in terms of integral x power minus 2 into dx I can write. Now this is in the form of integral x power n form. What is the formula for integral x power n? Integral x power n plus 1 by n plus 1 is the formula. So according to that one, x power minus 2 plus 1. Sorry, after integration we should not write the integration. So after doing this one, x power minus 2 plus 1 by minus 2 plus 1. So after integration, this value, how much you are going to get? This is x power minus 1 by minus 1. So that minus you can keep it in front. So this value you are going to get how much? That x power minus 1 you can make it to the denominator. So that what happens? This becomes integral dx by x square formula I can write as minus 1 by x I can write. So here I can put that one. So integral, this is integral df is equal to, formula is f is equal to nothing but I can write as minus 1 by x I can write. This total integration. Lower limit is how much? D. Upper limit is how much? D plus. Along with we have a constants are there, that is what is the constant? K, Q, L. Now if you solve this one, we'll get the required answer for this question. Now if you continue this, applying the limits, lower limit and upper limit, what you are going to get? F is equal to K, Q, lambda is constant, and the remaining whatever it is I can write as a limits as minus 1 by d plus n. Minus of minus becomes 1 by, okay, minus of minus becomes plus, and x value you can put as d. So if you solve this one, what you are going to get? F is equal to K into Q lambda into, if you taken on, and if you write in order 1 by d, okay, minus 1 by d plus L. If you take an LCM of this one, because according to given options to get it, KQ lambda into, that is d plus L minus d by d into d plus L or L plus d. So plus d minus d get cancelled. So after cancellation, what you are going to get? F is equal to, that is nothing but K Q lambda into, that is you are going to get only L by d into d plus L. So in this case, if you want to write in terms of any terms of charge, I can write this one as F is equal to K into, that is Q into, what is this lambda? Lambda nothing but charge per unit length. So we can write in terms of charge per unit length, we can write that we can replace later. Charge per unit length into d plus L I can write, and power we have here. So here this cell get cancelled. So I can write as F is equal to K Q square by, so lambda is equal to, I think we have a, okay, lambda is equal to not capital Q, that is small q by L I think, right? So small q by L. So I can replace here not capital Q, it is small q by L. So I can write, we won't get here square. So one is capital Q small q by d into d plus L is the solution. Look at this, check it this one.